Good morning. Good morning. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, January 29, 2022. Saturday, it's 3:45 a.m. नमस्कार, मैं सूरज सिंह भारत इंडिया से बोल रहा हूँ. मैं सिविल इंजीनियर. आज तारीख जनवरी 29, 2022 सुबह के 3:45 और मैं आपके सामने क्वालिटी इशू को लेकर हाजिर आपके सामने हेयर टू टॉक टू यू अबाउट क्वालिटी इशू. It's very important for everyone in life. Quality issue, and this is what I want to say to everyone. Read this yourself for a while and you know what I mean by that. Sleeping means we have to remove it, we have to get it up, and with that we are also sleeping, so we have to get up ourselves, and that's a issue is, and you can see this my name plate, name board, or whatever you can call it. I use it for this purpose to identify myself and let people know who am I. Very small person, ordinary citizen of Bharat, India, and you can use this email ID if you want to communicate to me regarding this talk or otherwise. And this is SURAJ. My name is Suraj underscore engineer, ENGINER at yahoo.co.uk. If you want to write, you can write. I am a very small person in profession as well as in life. This is my third certification as International Professional Engineer India, and this is my, of course, third certification as Chartered Engineer India. First certification was in 1981. That was AMI. Second was 1986. That was MIE. And third is 2016. That is MIFI. This is this one. And here is, you can say, this talk, which this is fellow. And here is what I want to discuss with you. I show you all again once again so that I close many of them, two of them at least, if not all. Which every experienced engineer is expected to have in this country. And here is, I can say I can close this file now, purpose is over. And I'll close this file, purpose is over. And it comes to you quality file, which is point of attraction, and you can say that is point of requirement. And also I am going to open another file which is for very important significance on projects, and that is blast wall, which we discussed already, but I continue to discuss. I don't want to bore you. The title of this is Get Up Quality. I say get up. Get up quality. Stop sleeping on hours, in hours. And I explained to you what is hours. Maybe many questions you. Many can question what is hours, and hours means our country. Generally, we never say our country in English language. This is not correct. When we say ours, this indicates that it is our country. We are talking of our country, and that is English version of this, is advanced English. So many points are there in English which I learned, though it's not English talk, but I'm just trying to remember and share with you. There was one teacher in my school, and he was, when I was in 1971, student of 11th standards in those higher secondary days. And that teacher still I remember. I'm just trying to reflect what is quality of education. It was not English medium school, it was ordinary school, very, very ordinary school, where I studied for 11 years, from 1960 or 61 to 71, 60 to 71. In that higher secondary final, that is 11th standard, I have 5 subjects. One is English, physics, chemistry, mathematics, and drawing, engineering drawing. It was Jain Higher Secondary School, Daryaganj, Delhi. This English teacher was extraordinary for me. I went for our class. extraordinary, or you can say outstanding, very veteran person, and sincere in teaching, very hardworking in teaching, had a different style which today we don't find. I think it's Mr. Bhardwaj, alright, and he was very strict as far as English was concerned, teaching standards are concerned. He used to tell us each and every specific word about English. I mean, so first of all, discipline requirements was that you have to enter class only with dictionary. You have to enter class with your shirt inside your pant. You cannot come out keeping your shirt out. And you have to stand in early morning prayers, keeping eyes closed. And just I remind you that this teacher, great teacher, was single, had no family. He never used chair to sit, he used stool because he had some spine problem. Well, that is personal life, but I'm just trying to tell you how people used to teach. He was very dedicated, very devoted towards the students, and he wanted to have a standard that his students must be excellent in language English. He always tried to keep students disciplined, and all students had respect for him. He had patience, he had knowledge, and he told us so many points which nobody else told us till today. For example, this I'm just telling you ours. He told this, he explained this. Never use our country, use ours. He also taught that when you use word need, for example, NEED, need, never use to after that, TO2. Just write need not or need this. Same way, he taught translation, grammar, and many other words. When some meaning was not clear, he would instruct you, open your dictionary and see yourself first. And if you are not able to understand, I'll explain to you what is meaning of that. I still remember he was teaching abbreviations. So what is abbreviation? And what is expansion, or you can full form of abbreviation? He asked everybody one by one, come on, stand and tell me what do you want to speak? Everybody was speaking something. Of course, we were students, we never knew anything. When my turn came and I stood and said my name and after said MP, everybody laughed. Because I did not know meaning of MP that time, but everybody had known that. So he said in his smiling and taunting way, see, this person has become member of parliament. He is speaking like Kashmiri style. Maybe he was from Kashmir, I don't know. Well, I am trying to say he was very amusing as far as teaching was concerned. He was very serious in teaching, and he never beat any student, never. But he taunted everybody. When some student boys' school, and once I trained heavily, some student didn't come that day. Next day, that person asked, the teacher asked that student, why didn't you come yesterday? And that student replied, sir, it was rain. Oh, he laughed in class itself and said, oh, बहन जी नहीं आ सकी, बारिश हो गई थी. बहन जी means sister. Because sister cannot come in rain, how can come in rain? So he just taunted like that, and students used to enjoy this teaching. And still I remember all those who specifically he taught us. That's what I'm trying to say. Language or learning is different if teacher is good. Today teachers are not that level. We have seen commercialization of education, every branch of education, every field of education. Commerce or making money comes first, and teaching goes to second line. You can say that time it was not only English language I am just referring to, it was mathematics or physics or chemistry or drawings, where I got teachers who is extraordinary, you can say. They never had any intention to have tuition, fee or tuition. Never they suggested any student that you come to my home, I will teach you. Never ever. It was science branch. I was not very good in science, but others were good. I cannot say that. And nobody attended classes except they requested for class only. Then they would say, okay, come on, this is my condition. They never accepted any award, any gift from any student. And that was character of teachers. They were not behind money. They were behind good future with help of teachers which could be achieved by students and by school. This was only requirement. That's why I can say that life which was very easy, simple, without any gadgets, without an electronic world, without any television. We have certain televisions in schools only for purpose of class, because every day there were some classes every 2 or 3 days in a week, physics class or chemistry class through television. And we used to pull out those big boxes of television from our center to our class for purpose of education. Otherwise there was nothing else except physical training or sometimes class games, or you can sometimes band or exercise like that. So I still remember purpose was knowledge. How can you get knowledge? He always used to say, that teacher of English, you come buy some paper and read it for 1 week and see which meaning you cannot understand. You open dictionary and have it known, and if you don't leave any part of that, keep it for 1 week and read every day, and read loudly so that your tongue is clear. Wow, it's an external talk, and we used to do that. And of course, that person used to say, whenever graduates visit westwards where English language is used, they say how good you are. We can't speak or write like you can speak and write. That was different. It was a part of education. I'm not appreciating English language or something. I'm just trying to reflect what was quality of teachers. That's what I'm referring all these examples just to let you know what does quality mean. At that time, quality was not sleeping. It worked very well. Those still who are alive from those era, those who were born in 50s or in 40s or in 50s, 60s, etc., 70s, not after that, I think. After 80s, or you can say in 80s series or decades or 90s, everything started turning out. I passed my schooling in 1971. At that time, politics was on peak. Change in politics, you can say at the time, it was a scenario of changing politics. And also then I passed my engineering diploma in 1974. Then I passed my further education of completing degree of engineering. That was in degree engineering in 1981. So I'm just trying to say there was a transition of quality up to 1980 or 85, you can say, there was good education in our country because of politics, and because positive politics, constructive politics, not politics like dirty and septic politics that has been going on now. In those days, every middle class family, I'm talking of middle class family, every middle class, I mean to say those who had some clerical job, or those who had some junior good officer's job, or who had class 1 jobs, or that type of people who had ambition to become doctor or engineer or chartered accountant, likewise a company secretary. Those families of middle classes people had certain you can say level of ambition that their kids should get, at least, if not more, to become a gazetted officer in government, or to become an engineer or a doctor. Likewise, these are very good ambitions in life. People used to think for future what my kid should be, teacher or doctor or engineer or administrator. Likewise, these were often milestones for family. I mean, not very moneyed family, but very ordinary family. And this could also reach to level of very, very low profile people who used to live in some hutments, or who used to work physical labor worker. And it means there was some social change economically, you can say. and political people, or you can say government, had policies in terms of 5-year plans that our welfare schemes must be for these people. And I am also beneficiary of one of those schemes. And really, I admire now policies of that time governments. I don't care government of Congress or what, but those policies were beneficial for a person like me, that I could, of course, I could not get much benefit, but at least good teacher, good professors, and ordinary education, but reliable education. I can estimate, I can assess today that in those days it was very generalized education. General in a way, if you pass some course, some degree, some scheme, some diploma, there was some job waiting for you. I still remember that time. I did not have any admission. I was in my higher secondary classes. Our drawing teacher used to say, or some other teacher used to say, when you just interacted in class during drawing session, make enough time they used to talk, just to inspire students or just know what students' mind. When somebody asks what is civil engineering and what is mechanical engineering and what is electrical engineering, in those days these were three main branches of engineering, or architecture, of course. And nothing else you can say. People didn't know anything else about other engineering. These are many, you can say, full-fledged engineering, civil, electrical, mechanical, and we were in drawing session, and drawing means mechanical. It's called engineering, of course, mechanical drawings. We used to learn mechanical part, plan, elevation, isometric, this and that. Means this was Jain Higher Secondary School. There was no biological science in those days. So we were forced to take this mechanical drawing session, and he used to tell us where you should go in future if you want to be something. And you get this engineering education, this is science of engineering. We could know that much only. Now, when asked, he said, never don't join civil engineering, because there is no future of civil engineering. There is no career in civil engineering. Better go to mechanical engineering or electrical engineering. In those days, the drawing teacher used to teach us like that. And we see, actually, when I used to call some electrical technician from Desu, there's a department Desu in our city, and we used to, electrician has come, he sees how so many people are following him, standing, how electrician working, or like say railway guard, you can say. You see, guard is very important, or just flags, waves, flags, train starts, stuff like that. So we were child with kids, and we did not have much more thought beyond that. So he told us better join mechanical or electrical, and also I had kept in mind that view. Okay, if I go, however, to degree, or I didn't know there was diploma also, but I could not get very good marks in my education, so I was forced to join a polytechnic college. And when I was questioned in interview which branch you like to select, I said, can I get mechanical engineering? He said, okay, no problem, you get mechanical. No, he was civil engineering. Likewise, I'm just trying to say, because there was a patience of quality and working. And our one teacher used to say, we have 30 students in this class and 30 students in civil engineering batch in Polytechnic. And our construction subject teacher just laughed, smiled all the time, teaching, to say, out of 30, even if 5 become diploma successful and become paraprofessional, we used to call at that time overseer. If you 5 become overseer, I would say I am successful. Means those teachers used to evaluate their success in terms of how many students can become this. Means you cannot expect all 30 to become that graduate of that course, but successful, to say. So teachers had also ambition for their students. And of course, same applied everywhere in university or in field. Every field senior engineer used to think that if my work is good, it shall be appreciated, and that was expectation, that people would admire my services. That was, you can say, individuality of quality system that time. There was no formal quality system. People did not even believe that time that some quality system can be structured. But quality name was not there. Of course, quality was there to some extent. Whatever engineering theory was available, whatever could be extracted of experience and knowledge. And of course, educational degrees were very, very important. Even diploma was highly evaluated. Degree was as if somebody has to be very expert or can say kind of person who has to work in design. And then of course masters and doctors were many, very, very few people were here. People as a thinking, those who have to go to field of teaching, they should join masters and doctors like that. But we also kept in mind it's only education that can change someone. My father was not very well educated academically, but by understanding, by experience, by struggle in life, he had always kept in mind my kids, my children should be educated well. Likewise, I can say about 10 to 15 or 20% families thought that way. There was 80% families who thought money is everything and business is everything, and my kids should not be worried about education. I shouldn't worry about that. If they get some higher class or matric or 8th or 9th education, that's enough for them. Everybody used to run shop and do some small scale business, but very few people had a desire for education. They didn't know what's meaning of education. They think that education is just waste of time. Of course, there was a problem of language, I can say. That was a real problem because our studies were in English, mostly those scientific subjects and other subjects. English was a problem for people because generally people did not understand English, and Hindi or other languages were not considered at that level as today we consider. Today, language is been understood to be a language only. In those days, English was not considered language, but as a you can say measurement scale of education. Though it was wrong, English cannot be a measurement scale, but because all subjects were English, that's why we used to say, if you know English, you can read, you can study, you can advance, you can go to other country and work there, and people work there. People used to migrate to other countries because of knowledge in English, and English was, of course, at least in more than 100 countries, was communication language. I cannot say in all countries, but it helped people to get jobs. That's also true. English, we were good in mathematics, we were physics students, chemistry students, physics, chemistry, or other subjects were dominating in English. Without English, you could not learn anything, and that's also true. Of course, it is engineering, and there was no such mandate that you must use correct English or correct grammar or translation. At least meaning should be convinced. And people wrote very good English, really. Translation from original language of Hindi or some other original language to English, it was well structured teaching. Grammar was considered very high, successful. Then there was subject like 10 short stories or poetries likewise. English was considered, if you had good knowledge of English, there was an opportunity that you can read any book. You could read any book from library or from market. And when you read books, you know that's part of communication, and you can expand your knowledge. If you read your own language, it means there's no harm you read that, but as far as profession was concerned, you might have, if you had better knowledge of English, you would have given better chances. And of course, we are not an English society. Speaking was a problem. Even after you learn grammar, translation, or good vocabulary, until you practice that language, and it's for every language, not only for English, and for even every mathematical subjects, you can say in engineering, if you don't practice, in like mathematics, don't practice, you cannot solve issues. Same way was subjects and learning. If you did not know English, even in classes, English teachers, language teaching was done in English, except in Hindi class or Sanskrit class. Means you have to practice, and we used to interact together in class in English, to broken English or whatever English, so that at least our tongue should remain open. So what I'm saying, as students were having certain quality standards, teachers had super quality standards, and still I remember today those teachers, I never personally had interaction with them. I was very coward student, not to raise questions in the class and not to ask. I thought, okay, I'll study later on. I was very, I have a hesitation in myself to raise some questions. I don't know why, but because I had no ambition. I had some economical circumstances that prevented me or that made me, made me closer. Okay, I'll see later on. I'll take notes from someone or I'll read myself, and that was my intention. And actually, it helped me. I did not raise questions in class, but I read again and again from books to know more and more. And that built-up habit from school itself helped me for self-education, and that is engineering self-education I did after passing my diploma. And still I am used to self-study. So it's sometimes quality develops in you. And what I'm saying is get up quality. We already had get up quality status in those days. School life, another life, get up quality. Teachers were quality one, students were quality one, and books were quality one. You can say everything. Systems were also quality one. Of course, there was no computers in those days, but even handwriting was a competition. Handwriting, speech, debates. I still remember Hindi debate in my polytechnic in 1972. I remember 72 or 73. I got second award, though it was first one I was to be given, but because of some reasons, so no, first should go to President of the Union. So I was given second. Of course, it was Hindi debate about industrialization in this country. Had it been in 1947, what would have been the subject in that? I still say that was, of course, very simple life in education, simple society, but was very important one. Now, keeping all these points in my careers, in my life, educational career and professional career, so far what I have gone through since my youth to today, I try to assimilate all these. You can say, I keep quality in my mind while including all these topics, and that is quality works. Work means whatever work. Teaching is also work. Same way, profession is also a work. And whatever you do otherwise, where some accountability is required, some money factor is required, some time factor is required, and necessary, it's quality works. And that's why I put questions on that in my title, and that is quality works, concrete specifications, civil field engineering, life engineers, and you can see contracts like FIDIC-based indications, and this AnnexSL, that is, AnnexSL is ISO 9000 related, whereas you can say others are Red, Silver, White books, and safety. And of course, then engineering world, that is of designs and construction, and contracts in engineering world, that is methods and contracts, and otherwise, of course, to follow further disputes, organizations, communication, coordination, and this also a part of communication and coordination that I'm just currently doing with you. I'm trying to reflect what I want to say in certain lines, and this for get up quality. Stop sleeping in hours. You think quality is sleeping? Of course, it's not sleeping. I can't say, but currently, because we are not serious, quality is still same. Nothing has changed, but our minds have changed. Our speed of thinking has changed. Our speed of patience have changed. Patience, we are not patient, and we want to just make money. One point in life is very, very important, and that is, where do you concentrate? That's the point. You concentrate toward knowledge, you concentrate towards work, or you concentrate towards money making. If you keep in mind unit of money making, then you can say you are nowhere. You may object this, why I'm saying money making, but fact is money cannot be made. That's the point. Money cannot be made. Money is related to economy, and you cannot make economy, you cannot create economy without availability of earth. If earth is not available, what shall you do? If knowledge is not available, what shall you do? You have money, Too much money? Earth is itself a money. If no knowledge exists, how shall you use this resource of earth, source of earth? So we cannot simply say economy is my target, or what salary I get, that is my target, or what should be my package, that is my target. And you cannot relate that to which branch of education you have to go to. It is your own happiness, your own pleasure, own future. How do you think and how do your parents think about you? Because a student cannot decide everything because of lack of knowledge, which others advise, and then a student can decide. So we can say quality, everybody cannot understand meaning of quality, but inference can be understood. Everybody wants to have good work, good product, and nobody wants to have bad product. That's also true. And sometimes those we used to call, oh, this is not good product. Sometimes, oh, this is very good product. There was no relation how you could call good or bad. It was only use of product which helped us to understand what is good or what is bad, what was good or what was bad. So that's what I'm saying. Now everything has been channelized through engineering. So we can say engineers can handle quality successfully, and it's their job. And we ask quality, you get up please, you are sleeping. And quality says, I am not sleeping, you are sleeping. So there's a clash between two, quality and individual. Quality says, I am there, you do not care for me, that's what you cannot have me. And person says, no, I am there, you are not coming. Who is right, who is wrong? You think your way. But quality is not an individual, it's a state of work. So how do you say get up quality? Quality is already getting up, it's there, you are, so you get up. So I can say, when I say quality, I apply quality to an individual. So individual is also a quality. We say, oh, this person is excellent, outstanding, sincere, this and that. And you say this person is a quality one. So this person is also quality. So we can say get up quality. So I can say get up you, please get up. You are quality. If you are quality, there would be quality. If you are not quality, there won't be quality. You can say that. So quality is not the state alone. It is individual. It is material. So I am speaking to myself, I am addressing myself, and everybody has to address itself. I am a quality. If I am not a quality person, I have to make myself a quality person. And if you make yourself a quality person, I think problem is solved. I am asking myself, and you ask us, get up quality means get up myself, and I want to sleep. And quality says, no, stop sleeping in hours. Quality cannot sleep anywhere in the world. It's like soul of your body. It's like mind of your body. Soul and minds never sleep. And engineering is equivalent form of quality. Quality and engineering are directly proportional to each other. If engineering falls, quality falls, and if quality falls, engineering falls, and if quality falls, individuals falls. Quality absence means mind absence, engineering absence, and you can say every part expense drops. Engineers can handle quality successfully because they are educated in technology. They are educated in production, in construction. That's meaning of engineers, and that is through logic, not through arbitration. Oh no, I say do it. No, it's not through that. It's not arbitrary arrangement, it's logical, scientific based arrangements. And that's what engineering is. We have to be very smart as far as this is concerned. We have to consider all these points, and then only we can move forward. So we require to establish you permanently, and that is quality. This means we have to establish ourselves permanently in standard mode. When you explain these types of very small phrases into explanations, books can be written on that. But I'm not interested in writing books. Books are written, there are thousands and thousands of books available, but whatever we are talking, that is not related to books. Who reads books these days? People don't believe in writing, or I cannot exactly say not believe, but they don't write, I have seen. They don't write and they're not also very interested in reading. And if you see standards of writing, you can refer to whatever newspaper or whatever the written medium. You will not find highest level of quality even in writing. You can read or you can view television, you can read something, you will not find any standards anywhere. You can say skills which are helpful in communication, those skills are writing. People say penning down, writing, or video talk, or you can say conferences, or reading, or whatever it used to be, knowledge transmission devices or ways, those have fallen. I've not seen nowadays people writing even on Facebook or some other social websites. You will find only photographs or videos. You shall not find any knowledge dissemination in writing form, written form. So we can say skills of writing and reading have gone somewhere. We cannot see those destinations. And I don't think this would come back so easily. We used to write a lot while I could not remember some topic. And I could write so that writing could help me remember that. And that's a really important communication medium is writing and speaking or reading. These are absent in general. Absent, you can say. And when these are absent, means people nowadays believe in listening only or speaking, but writing is very poor. Writing and speaking are different worlds. It's not essential whatever you write, you speak same, or whatever you speak, you write same. Writing language is always a structured one, whereas speaking is not a structured one. A speech can be ambiguous, it can be withdrawn. People say, I did not mean that. It's very big trend these days. You speak anything, and if it goes to news, then you have to, oh, no, I did not mean that. My words or my sentences have been misunderstood. And this is very common. This is very common, response these days at every profile, at every level, from educated people to politicians and all those who do not want to have any responsibility. So that's why I say we require to establish quality. We have to get up quality. We have to get up ourselves. We have to stop sleeping. We have to stop ourselves from sleeping, and we have to, as engineers, we have to handle quality successfully and establish quality permanently. Have active quality performing applications, and when issue comes to applications, this is a very big issue, because application means part of engineering, and every engineering, it may be design engineering or practical work engineering, these are all parts of engineering applications or engineering activities or events, and these are all related to quality of safety, health and environment, somewhere directly or indirectly in a sufficient way. And what we say really, it is it all requires engineering approach on working, and working means work on designs and work in manufacture and work in construction itself, construction procedures. So when we are active in our works, when I say applications, this means engineering works. We have to care about first our own safety, then safety of work, safety of in future, and all this can be done only through engineering approach. Engineering approach to engineering world, engineering approach, personal approach to engineering world, And when we say engineering world, this means working designs, before that other designs, and then process of manufacturing, and of course then process of construction procedures. Construction procedures, which I think everybody knows to some extent only, but we have to learn procedures. We have to learn methods. And only by that we can create or we can do more methods, and we can know what is meaning of method. We have to assess our work, we have to assess our considerations, and what we have to achieve in life. How can we achieve something better than before, every time better than before, or we have to lock that better than before, and so no, we have to achieve only this level. This is my datum line, and I don't want to get more than this, and also not less than this, and I have to fix it. So what I say, if you have to talk of construction, we have to talk of development, we have to talk of all this, we should have logical deliberation. That logical deliberation comes through our contemplation. I cannot simply say or announce that I do quality work, and I do not do actually. I announce only. And if I think just by announcement I will become successful, I repeat that just to deceive people. I do not do that, but I say I do that. Means self, you can say denial. If I say I declare, my declaration is adequate, that would sell. Again, point comes, that would sell. I don't want to sell. I can't sell everything, and if I sell everything, then I have no mind. Why should I sell? When I have good, strong item with me, it's useful for me. Why I should sell that? That's point here. We have to fix quality in our country, ours. Come what may, we have to fix it. No excuse for concessions. Fix quality in Bharat, India, come what may, no excuse for concessions. And when I say quality, this means quality in part, in work of life. It may be professional life or it may be your personal life. Quality must be everywhere, must be available, and it must be seen available. But we have lost it, that is not good. I have talked many times, I have written many times, many posts, but no response from anywhere. And that is really surprising, that people are not even interested to refer to such talks. Reason unknown. I don't know reason. But reason or no reason, interest or no interest, if you have to move your country forward, you have to do all what is required to be done. And if you don't do, then you cannot achieve anything in life. Life achievement means engineering relations. I don't say everybody should be engineer. I don't say that. But engineer should apply to world. It should apply to our world, our geographical world. It should apply in our transactions, business, knowledge of rates. And it's very easy to buy something if you have money, but to know something about that is engineering. How to know about that? Therefore, I can say I give engineering detailed quality system. I don't want to have an excuse, and nobody should have an excuse about fixing quality in Bharat, India. No concession can be granted to that. And we can say works quality, quality works can say, quality and works quality cannot be compromised just in name of fragile quality system compliance, formality and excuse. And I say if I cannot bring quality just in name of fragile quality system, we have to think different way. I'm not invoking any criticism, but reality. Maybe our people did not understand meaning of quality, but they did some work, whatever, with seriousness. If you had learned, again I say, seriousness pays us, and seriousness definition is not what you think. This person is serious, very serious or serial, and I would say it is state of mind, how it works in this seriousness. Sometimes seriousness resolves many problems, and sometimes it becomes itself a problem. So we can say we cannot compromise any quality requirement. We have to do it because it is in hands of those who deal with quality. I do not need my quality system to hang all the time in some picture box or some box. It should work. It should work. That's only one requirement. And if it doesn't work, this means you spoil material, you spoil time, you spoil whatever else activity you take care of. And if these points do not combine together as individual or as family, then all these diseases show. Whatever you do in the name of God, that God, no link. So we can say we have to worry about quality, must perform, it must be delivered, otherwise there is no meaning of that. It doesn't happen currently in the entire scenario in ours, Bharat, India. And there may be many reasons for that, which we have already discussed, and can we bring them back. And that's why we raise many questions and explain this one day, other day, and try to remind it all the time, which are very important points we have to worry about. When I come back to real quality in engineering, and that is concrete quality, which is of course very important point here, quality of contract. And that day I was talking about scientific term, engineering term, and that's blast wall. We have gone through that, some discussion. It was then passive safety barrier we're talking of. For that, managing domino effect and maintenance, plant and operations. And we have inherently unsafe safety issues, planning a new facility, and that is inherent unsafe safety issues. This was in conclusion. So let us see what was here. I left somewhere, and that's here. So domino effect we are talking. Let us go to we can say it is Bay Area. Let us say industries we are talking here. Before that we are talking about this paragraph. Let's see what it was. Domino effect. Composite panels, I think we had done. Composite panels of blast. We did that, and fiber reinforced composites. So now we see domino effects, predictions and prevention. And this is by Missouri Valley Originally, method of chemical process safety. Now is passive safety barriers. Passive safety barriers. It says passive safety barriers are generally physical measures such as coatings and materials for thermal insulation. Passive safety barriers are generally physical measures such as coatings and materials for thermal insulation of equipment, firewalls, blast walls, which do not, these coating materials for thermal insulation of equipment, firewalls, blast walls, which do not, you know, do not require external activation, to perform required or respective intended safe function. This can be designed both as prevention and or mitigation barriers. In a specific case of domino effect prevention, passive barriers are particularly important since they are immediately available when primary accident happens. In the absence of response time and their permanent availability, that's meaning that their probability of failure on demand is zero. The probability of failure on demand is zero makes these measures particularly effective in escalation prevention, also with rapidly evolving scenarios as fireballs or explosions. Indeed, for these scenarios, only passive mitigation measures, namely thermal insulation or blast walls, should be deemed effective. Nevertheless, installation of this type of barriers might introduce cost and complicate maintenance operations. Considering example of vessel mounting, these issues are clear. And implementation of these solutions is usually limited to peculiarly critical elements in layout, as control rooms, warehousing, storing explosive materials. So I repeat this paragraph just for re-understanding. In a specific case of domino effect, prevention passive barriers are particularly important since they are immediately available when primary accident happens. Of course, in the absence of a response time and their respective permanent availability, that is meaning the probability of failure on demand is zero, makes these measures particularly effective in probability of failure on demand is zero. Makes these measures particularly effective in escalation prevention, also with rapidly evolving scenarios as fireballs or explosions. For these scenarios, only passive mitigation measures, namely thermal insulation or blast walls, should be deemed effective. Nevertheless, the installation of this type of barriers might introduce cost and complicate maintenance operations. Considering examples of vessel mounting, these issues are clear. And implementation of these solutions is usually limited to peculiarly critical elements in layout, as control rooms, warehousing, or storing explosive material. Probably most important passive mitigation barriers when dealing with liquid spills are catch basins. Probably most important passive mitigation barriers when dealing with liquid spills are catch basins, which might have a key role in context of domino effect, mitigation and prevention. Indeed, these measures contribute both to limit spread of flammable liquids, spills and possibility of full fires reaching to other equipment, as well as pool evaporation rate, reducing likelihood of flammable formation, and vapor cloud explosion. Another example of relevant passing barrier is case of passive protections for heat radiation. Passive protection for heat radiation. Heat reduction. Heat radiation reduction such as firewalls and fireproof materials. These measures are indeed effective in reducing likelihood of loss or medium. When say loss of target, these measures are indeed effective in reducing likelihood of loss of target, mechanical integrity by reducing heat load, impacting their surface. Clearly enough, passive fire protections should be integrated with active and procedural barriers as firefighting or depressurization to achieve interruption of a domino chain, since these are only able to delay heat up of vessel. Industries. Valve area. Following spatial should be considered for valve area. That's a specific area. It may require separation from other process area by fire or blast valve. It may require separation from other process areas by fire or blast valves. Use of splash valves for this separation provides protection only against contamination from drilling fluids. It should be accessible for personal escape and firefighting on both sides of platform. It is, just trying to find more in this. It's about, let us see what is that for this of work. Okay, let's go this way. First of all, let's finish this. Waiting for it is about. So it should be accessible for personal escape and firefighting on both sides of platform. It should be clear of permanent equipment for full width of platform for drilling and workover rigs. It should be clear of permanent equipment for full width of platform for drilling and workover rigs. No equipment should be located in wellhead area other than wellhead fittings. Wellhead, the understand is wellhead. No equipment should be located in wellhead area other than wellhead fits, including wing valves, flow lines, individual gas lift, individual gas lifts, gas injection, well kill water injection or chemical injection lines, and parts of platform safety systems which serve wellhead area. So no equipment should be located in wellhead area other than what we have: wellhead fittings, including wing valves and flow lines, individual gas lifts, gas injection, well kill, water injection, or chemical injection lines, and parts of platform safety systems which serve wellhead areas. And we have valves other than wing valves Instruments, vent lines and drain lines should be outside the wellhead area where practical. Now sufficient the clearance above wellhead should be provided for installation of wire line blowout preventers. Process piping required to traverse well bay area should be routed outside of wellhead area. Manifolds for gas lift, gas injection, water jetting, well kill, chemical injection and blowdown of wellhead piping system are permitted in production deck well by area but should be outside wellhead area. Generally, manifolds should be located 4.5 meters space between outside well rows. Accommodate manifolds rows and skid trusses. It may be necessary to increase this space to accommodate manifolds for large high capacity wells, flow lines, and in these cases it may be preferable to locate manifolds or can say high capacity wells, flow lines, and these cases may be preferable to locate these manifolds on only one side of valve area. Control panels with instruments related to the individual valves and equipment with safety systems for valve area generally permitted in valve area. Test separators located on production deck in valve area are permissible provided they do not restrict explosion venting in wellhead area to extent of exceeding design overpressure. Now overpressure affects its conclusion here, and I think let's do this and we close this later because there's nothing left in that. I'll put my battery off for time being. Hold on please. I put my battery for time being. There's also a requirement here. So conclusion here is effect of accidental explosion. Effect of accidental explosion on industrial equipment is hardly predictable. That's also true. Means you cannot predict like that. You can say says that effect of accidental explosion on industrial equipment is hardly predictable. I removed my blanket, so it's cold. I put blanket up again. Anyway, it's like that. What can I expect? So we go to that one. How to have it, Effect of accidental explosions on industrial equipment is hardly predictable by deterministic approach, and even assessment of resistance of a simple flat blast valve for protection of a residential unit on an offshore platform by considering idealized triangular blast valve in design phase is a matter of debate and requires complex numerical analysis with large uncertainties in results. However, it is possible to carry out a reliable assessment of possibility of an escalation either by simplified or by most complex methodology. Simple models, that is SDOF, simple models, single value criteria, PI diagram, can be used by whoever experienced risk engineer. Results of these simple approaches are conservative and enable risk engineer to make a reliable statement concerning possible exclusions of escalation. Probit model for damage to equipment caused by blast waves are available in literature and can be usefully adopted for QRA and land use planning. If damage probability data for different process equipment categories is separately considered, use of probability functions and threshold values for occurrence of LOC from damage system is crucial for analysis of escalation resulting in domino effect. When risk engineer comes to conclusion that escalation due to blast load cannot be excluded, a more comprehensive dynamic response analysis is needed. This can only be performed with aid of several experts. Explosion modelers, finite element experts, each having extensive expertise in their own field. Substantial cost increase of design engineering is, however, to be expected. Now, inherently unsafe safety issues in planning a new facility. There may still be hazard of an explosion. Even after all provisions have been provided to reduce risks. Residual risk can be controlled by use of blast walls. Or blowout panels. If hazard is in a building, this channels direction of blast in a safe direction. One-time crankcase explosions occurred in large marine diesel engines, and ships caught fire and even sank as a result. Investigations revealed that overheating of bearings caused explosion. If crankcase oil was also contaminated with fuel, hot bearing could vaporize an explosive mixture and ignite it. If crankcase oil was also contaminated with fuel, hot bearing could vaporize an explosive mixture and ignite it. Design provisions removed this hazard. Crankcases were fitted with blowout doors and flame arresters. This controlled explosion and prevented fire breakout. In modern engines, besides blowout doors, beating temperature and crankcase vapors are continuously monitored so high hazard can be avoided. Safety in designs. Although fireproof insulation is passive, it doesn't need regular maintenance to check integrity. Although fireproof insulation is passive, it doesn't need regular maintenance to check integrity and adhesion to plant or equipment. They protect. Whenever apertures are made in fire or blast valves, namely in cable or pipe penetrations or access doors. They should be maintained in equal or greater fire resistance than wall itself. Cement-based fireproofing materials are not necessarily ruined. Cement-based fireproofing materials are not necessarily ruined after exposure to a short duration fire. Usefulness of remaining fireproofing depend on how much water of hydration was lost, which itself will be a function of intensity and duration of fire. Nevertheless, once fireproofing materials have been exposed to fire, these should be replaced even they do not appear to be damaged, because concrete may have lost strength due to severe temperature gradients that it experienced. Long-term environmental exposure does not generally have much effect on fireproofing material. Passive safety barriers. Inherent safety strategies are applicable mainly in basic design activities. Inherent safety strategies are applicable mainly in basic design activities. Passive protection systems are usually implemented in more detailed design stages. Passive strategies consist in general in use of physical barriers, thermal insulation of process equipment, fire resistant walls, blast walls, etc. This can be applied both as prevention and or mitigation barriers. In case of domino prevention, passive barriers have a distinctive value as mitigation safeguards, since by their very nature are immediately effective at instant of primary accident. This null response time makes passive barriers effective in preventing escalation. Also for scenarios that are rapidly evolving or that are difficult to detect, for example in case of heat radiation originated from fireball scenario only, passive mitigation system. Thermal insulation should be considered effective, since rapid evaluation of scenario in general of order of 520s exclude possibility of active protection system. Same applies to protection from shock waves originated by explosion scenarios. In some cases, as fragments projection, passive barriers can be only applicable mitigation measures. Since inherent strategies may not be applied in practice, that is, namely excessive segregation. Excessive segregation distance CSB report on Bayer crop science accidents in 2008, US Chemical Safety and Hazard Investigation Board presents an analysis of protection provided by blast blanket in case of fragments impact. The report refers to specific case. It evidences as blast protection can be an effective solution for mitigating damage from both small and large missiles. However, design of supporting structures must specifically account for expected dynamic loads, since deformations originated by impact may as well damage piping and process equipment. Passive protection from heat radiation or flame impingement. passive protection from heat radiation and or flame impingement, fireproofing, firewall, etc., may be very effective in slowing heat up of structures in a However, in case of flame impingement, integrity of protection is critical since hot spots may be formed in presence of defects of insulation, leading to local stress, overheating and failure. Catch basins are a particularly effective form of passive mitigation barriers when dealing with flammable liquid spills. They contribute both to limit extension of possible impingement scenarios as well as evaporation rate, cloud formation and subsequent possible trenches and impounding basins positively contribute in a similar way. Passive protection can also be effective for mitigation in domino chains involving blast waves or fragments. Walls, blast waves or fragments as propagation vector. However, installation of barriers such as blast walls, mounding, etc. can introduce significant costs and maintenance issues that have to be carefully considered. As a matter of fact, use of these barriers is limited to protection of most critical structures in plant, control room, critical equipment, storage of explosive material, etc. Use of composite and composites in blast resistant walls. Use of fibrous laminated composites, and before that let me see other chapter as well which I have to talk about. It is about it's only small live action video of VR down let me put link to this. Blast structures have a wide range of blast resistant windows, and let us see what is this. Only 2 or 3 pages in this, but let me see what is that. Can we print it and see what it says? Let us see. Before going further, let us I just want to select something here, and that's what I say. Okay, I'll print it and see how this works. Use of fibrous laminate composites in blast protection is discussed in this chapter. Use of fibrous laminate composites. Different ply settings, composites and different ply settings, that is unidirectional, UD woven roving WR and chopped strand mat CSM lamina are considered. One is unidirectional and other one is woven, rowing, and then chop, stand mat, CSM. Lamina are considered. These examples of use of composites, namely, or for example, in strengthening existing corrugated blast walls and their connections. In separate so we can say, as we said here, you know, three examples of use of composites, namely strengthening existing corrugated blast wall, strengthening existing corrugated blast walls and their connections in replacement of blast walls by composite sandwich panels and in use of fiber metal laminates are discussed. Examples are selected to reflect range of applicability of composites in blast resistant design. That is, which includes offshore, defense and marine industries. Problem of connecting composite and hybrid parts is addressed. Results included are adopted from literature on topic or are results of analysis conducted by authors or by their affiliated research group. It's settled. Results included are adopted from literature on topic or results of analysis conducted by author. It's settled that composites can be best used in conjunction with other materials. These metals can be metallic such as aluminium or non-metallic such as balsa wood. Hybrid settings can be used for low and moderate blast loading levels. Problems of designing hybrid parts using fiber-reinforced polymer comprises for use in high pressure, high impulse blast. Hybrid settings can be used for low and moderate blast loading levels. Hybrid settings can be used for low and moderate blast loading levels. Problem of designing hybrid parts using fiber reinforced polymer FRP composites for use in long term. We can say problem of designing hybrid paths, impulse blast hybrid paths using fiber reinforced polymer composites for use in high pressure, high impulse blast has not yet been fully solved, and further research is required to proper insulate and We go now to some other one page, that is gas and vapor cloud explosions. Gas and vapor clouds, cloud size and location control barriers. Cloud size and location control barriers. Main purpose of this class of barrier is to minimize volume of flammable gas that a gas explosion is allowed to consume, and to control location of this volume. Generally, overpressure load on structural surfaces is expected to increase with increasing size of an explosive gas cloud. Generally, overpressure load on structural surfaces is expected to increase with increasing size of an explosive gas cloud. It's therefore important to limit size of potential accidental explosive cloud as far as possible. Most commonly used barrier type is blast wall. In some cases, a main function of blast wall is to limit size of explosive cloud. In other cases, its purpose is mainly to reduce impact of potential explosion. By shielding structural outside walls from excess overpressure loading. A point is pointed out concept of using a wall to restrict size of explosive gas cloud also includes weaker walls than blast walls, and even deliberately weakened walls. Feasibility of process, you can say here is, I said, concept of using a wall, as pointed out, concept of using a wall to restrict size of explosive gas clouds also includes weaker walls than blast walls and even deliberately weakened walls. Feasibility of concept of weak wall explosion barriers was investigated by team. Pressure area was divided into halves, you can say. Pressure area was divided into halves using various arrangements of weak wall. It was shown that maximum overpressure developed in the structural surfaces could be reduced by 50 to 75% depending upon arrangement of weak barriers. Soft barriers are very weak and light physical barriers walls. This type of barrier offers possibility to separate an area into a number of separate cells, allowing controls of size and location of accidental gas cloud within a hazardous area. Soft barrier control method has been used on oil and gas platforms. Soft trigger barriers. Soft trigger barriers are non-superfluous, non-suppressive, you can say. Soft trigger barriers are either non-suppressive or suppressive. Most commonly used non-suppressive soft barrier is water curtain. Water curtain that has no specific suppressive effect. According to someone, such curtains have been used successfully in process industries onshore to contain hazardous gas clouds within a limited area, or to divert such clouds to safer areas. A number of extensive experimental research programs comprising various scales up to full size have demonstrated that water spray barrier can be effective in containing hazardous gas clouds. However, some types of water curtains are also categorized as suppressive barriers. Experiments have shown that this type of curtain, in addition to limiting the size of dispersing explosive gas cloud, also causes flame propagation to decelerate as flame passes through curtain. Effect is a significant reduction of maximum explosive pressures. So we move to other one. Just now I said this blast resistant products. Now here is, first of all, let us say bullet resistant products. We have Windows UL under Lighter Laboratory 752 labels all this rifle, handgun, all of it. This is some products this company is giving. Surface options, tempered, heat strengthened, annealed, chemically strengthened, clear, grey zone, grey, green or brown stents. Manufacturing options are for bullet resistant, that is fiberglass UL level 1 to 8, rifle was handgun protection, then glass clad polycarbonate, LexGuard acrylic, and glass pen is 4x8, steel and aluminum, composite material, maximum size 4x8, lightweight, lightweight bullet resistant composite panel, window frame UL level 1 to 8, rifle handloom protection. So we can say here, this is maximum size glass clad polycarbonate, LexGuard acrylic, maximum size 4x8 glass pan, steel and aluminum composite material is maximum size 4x8 lightweight bullet resistant composite panel, window frame UL level 1 to 8, rifle and handgun protections, doors, frames and store front systems made from steel and aluminum, multiple locking systems that can stop an AK-47 and 2 hours intrusion, certain Now, maximum size of 4x8 lightweight bullet resistant composite panel, window frame UL level 1 to 8 rifle plus handgun protection, door frames and storefront systems made from steel and aluminum, multiple locking systems that can stop AK-47 and 2 hour intuition. We can then building can be, we can say, of course, building can be manufactured from steel, stainless, bronze, and aluminum. Ship and aircraft security protection from RPG, composite offers, rifle and handgun protection, bullet resistant bridge systems built with glass and door. Now, glass resistant product. Windows and frames tested with, equivalent to okay, these are products, leave them behind. Products used sporting events, VIP conferences, parades, marches, elections, civil and destroyers, natural gas plants, police and military crack joints, embassies, port connections, customer alerts, areas, entertainment venues, hotels, naval ports, government offices, public and private utility compounds, and military backdowns, and of course. Then we have to say one is about us. Let us say what this company says. 45 years of engineering, designs, and manufacturing makes glass structures one of most successful companies worldwide. Glass structures manufactures world class quality, ballistic grade building structures, along with retrofit components suitable for defending against a wide variety of threats of more violent nature, both humans and nature indeed. So, Okay, so we can move forward in this discussion. Applications in commercial, government, residential emergency preparedness for numerous types of unanticipated threats to personal safety as well as safeguarding available personal property, whether risk is accidental or intentional. And these structures inside doors, windows, wall panels, safe rooms, and mobile units for both new and retrofit. Technology and engineering used in creating our blast structures have been used successfully in a number of governments and commercial facilities around the world. A live action view of blast structure products turned up before make this video, and then the actual video of actual testing acting. So here is some say blast windows. It is blast resistant windows, and here is a lightweight bulletproof composite material, and here is curtain wall and window protection ranging from handgun to shallow rifle. Protection against the technology. We have protection against terrorism up to 1000 lips of tint hair, and here is, you can say, blast resistant building, safe zone bullet, and there is this one. Car bomb blast barrier, and this is a bullet resistant car barrier, protection against terrorism. Okay, then it is not that much important. Let's say we go back. So we'll see something else here, and we saw those things. So we have solar blast structures. Comparison of responsive building structural blast, best blast effect on structural elements. Let's see what it says. Let's open this first of all. Best effects on structural elements. Let's see what this speaks about. It's not coming. This is page 29, blast effects of structural elements. So here is what we do. It's author information. Show in last the case number of terror. Okay, terror effects. It's no problem. We are not here. So that. Let's see what this introduction states here. Test campaign. It is field test campaign is designed to, depending on structural element to be analyzed. A previous work is carried out. A previous work is carried out to calibrate particular parameters such as scale distance, standoff distance, or height of change. Due to uncertainties of this kind of tests, sometimes it's necessary to correct the specific parameters along tests to obtain desired results. The best result to get as much information is possible from rest is to produce an intermediate damage. When a structure collapses, no information can be extracted after explosion. Same happens when damage is minimized. Therefore, an intermediate level of damage is best option to analyze blast effects on structures. Now here elements to be tested are constructed with representative size to avoid scale effect. Boundary conditions are reproduced as similar as possible to a real situation. To analyze improvement of different retrofitting materials, a non-reinforced element is always tested as a controls element, that is known as explosive used in test we reported by below was plastic explosive for military use, similar C4 with experimental and TNT equivalent based on impulse of 0.86. Several parameters are measured in tests to characterize explosion. Tests are monitored with pressure gauges, accelerometers, high-speed cameras, conventional cameras, last scenery, scanner where possible to equipment to measure velocity of detonation of explosive with a high speed recording device. These data are then used to calibrate numerical simulations. Several parameters are measured in tests to several parameters. Let us see this. Several parameters are measured in tests to characterize explosion. Tests are monitored with pressure gauges, accelerometers, high-speed cameras, conventional cameras, laser scanner where possible, or equipment to measure velocity of detonation of explosive with a high-speed recording device. These data are then used to calibrate numerical simulation. After a test, a series of measurements are collected for further analysis. Rebound value measured and a skipped hammer following a methodology developed combined with surface damaged area, spalling, mass, length of cracks and displacement. Damage assessment. Considering all data collected in field tests, damage evaluation is made combining visual observations and analytical methods. Combination of both methods allows to establish a classification of damage which ranges from moderate damage to collapse. Visual observations provide information about condition of a specimen after explosion, such as cracks, failure, pattern, debris. However, this kind of analysis does not allow to check if there is internal damage. To fill this gap, analytical method a methodology based on rebound principle with a Schmidt's hammer is used. Damage based on rebound number. Damage based on rebound number. Damage based on rebound number. Method based on rebound principle. Method based on rebound principle consists of measuring rebound of spring-driven hammer after its impact with material surface to check its uniformity. For damage evaluation, objective is to find a variation in rebound number after a blast event and not direct spring correlation. For purpose, a series of measurements on specimen are done. One measurement location point is defined by 12 points inside a template. One measurement location point is defined by 12 points inside a template. 6 for evaluation before and 6 for evaluation after explosion. Q1 is median for 6 points evaluated before test, BI, being corresponding number that goes from 1.06 1.16. Now you can say Q2 is median for points after test. Both medians are then compared using Wilcoxon rank sum test. If value lower than 0.05 may confirm a decrease in rebound number after explosion with 95% confidence level, and hence point analysis the rebound number raft points samples used for slab right, and right point template is for bricks. So this is figure 1. Here is 7.5 centimeter square and this is 5 by 10. This is figure 1. This is model of templates used to measure rebound number. Left point template used for slabs, right point templates used for bricks. Model of templates used to measure rebound number. Left point template used for slab, right point template for bricks. And for this purpose, damage D is defined as D, and that is D is equal to 1 minus Q2 or QA if P is less than 0.05. Q2 or QA, 1 minus Q2 or QA if P is less than equal to 0.05, and D is equal to 0 if P is greater than 0.05. Damage ranks from 0 to 1, 1 being a damage of 100%. In order to complete damage analysis and based on results obtained, a damage or contour map is created for this purpose. A grid of 200 linearly spaced points is created for each specimen at each direction. Then a fitting surface to data with a triangle based cubic interpolation already implemented in MATLAB is calculated and protected. With this data, parameter called global damage D200 is obtained. This parameter is calculated with mean of 200 points of grid. In this parameter, an overestimation of mean damage is reduced. Relative area of damage and crack lengths. To complete damage evaluation, two parameters To complete damage evaluation, two parameters related to surface damage can be used to rank structures' behavior based on visual inspection and not in damage maps. Relative damage area is defined as ratio of surface with total damage over total surface of specimen. Crack length defined as sum of length of all cracks presented on specimen can be used as another additional parameter for damage evaluation. After spalling mass, I'm talking after a blast event, fragmentation is major source of wounds when structure does not collapse. Mass of debris and distance to which they are projected can be used as potential damage parameters of explosion. The four spalling fragments Spalling mass after a blast event, fragmentation is major source of wounds when structure does not collapse. Mass of debris and distance to which these are projected can be used as a potential damage parameter of explosion. Therefore, spalling fragments are classified and weighed after tests. As these parameters only obtained in some tests, general comparison and conclusion with the rebound area are not possible. Displacements. In order to obtain more information about the structure's behavior, tests are monitored whenever possible. With a laser scanner measuring geometry before and after event. In other cases, maximum deflection of element at end of test is measured to assess final degree of damage. Structural elements. So the destructive result of test together with short duration of both blast loading and response to structural limits, opportunity for depth understanding of process involved. Therefore, the use of 3D full-scale finite element modeling is fundamental to understand, predict and simulate failure mechanism and damage area of structural elements against blasting. Numerical modes are conducted using LS Dyna software, which is based on explicit numerical methods that are suitable presented in different constructive elements. All these carried out full scale in all cases. A study included field test, damage assessment and numerical modeling. All tests shown here were conducted at Technological Institute at La Morsa. Alright, then masonry walls. Masonry walls. Total of 4 masonry walls tested in 2 different trials are included in this chapter. These walls were built inside a concrete structure, simulating real situation of building. For each shot, 2 boxes or rooms, box A and box B, were built with 40 by 20 by 20 centimeter masonry concrete blocks joined 3 by 3 by 3 meter with a wall, 1 meter separation between walls. So we can say I would say lateral and back walls are reinforced, filling hollows with mortar and steel bars. Evenly spaced in horizontal vertical directions. The frontal wall was a continuous wall covering space between boxes and projecting 1 meter with both sides in order to increase impulse load over walls. Both rooms had an access door by central corridor. Different coatings were implemented. Different coatings are implemented inside room for debris assessments. Each box inner face of masonry wall was partially tiled and rest was pointed. After first test, frontal wall was rebuilt for second trial. Explosive mass 5 kg was EQNT. This is, you can say, it's P3 here, P1 here, 100, 300, 140, 330. This is length of this. So 400, 540, 640, and 940. The total of this and front view, and this is there. Because the box way, tiling, pointing, tiling. Okay, we go this way. Test setup and details, and test M1, test M1, M2, test M1 box, a non-reinforced wall for comparison. Other one is aluminum mesh anchored to external face of wall and exposed to explosion, and then a glass fiber reinforced sheet glued with a polyethylene adhesive in external side of wall. Basalt fiber mesh attached with cementous mortar. The results show the main results. So these main results are obtained from test instrumentation pressure and impulse from pressure gauge and shock wave velocity from high speed video. So these are test location, distance, scale distance, pressure, impulse, shock velocity. Test in M indication, location P indication, distance in meters, scale distance meter per kilogram, 1/3. cubic, scale distance is meter per gram over 103. That's cubic contents of this, and pressure is kPa. Impulse is kpms, and shock velocity is here. So we can see that. So many readings are here, and important. This kPas, and this is this result title is main results obtained from test instrumentation. This pressure and impulses from pressure gauges and shock wave velocity. Pressure gauge results and shock velocity measurements. What says that transducers P1, P2, and P3 were measuring reflected pressure with P4, P5. Were measuring side-on or incident pressure. P6 registered peak pressure inside box B. So P1, P2, P3 reflected pressure. P4, P5 measuring sides of incident pressure, and P6 registered peak pressure inside box. You can assume these are substantial pressure variations, and vertical component because triple point higher at 5 meters from charge is higher than wall height. Result less on are from test M1 with exception of ASV6 that comes from test M2. Measurements from transducers P1 to P5 for test M2 were lost due to failure in equipment. Pressure results accompanied with manual from Department of Defense USA. And there is this scale distance, pressure measures compared with UFC, data shock wave velocity compared with UFC. So there is the scale distance and the GMK, the two different are. One is here between scale pressure and scale distance, and here is shock wave velocity and Z, both are there. Incident and reflected, and here is shock velocity versus Z. Shock velocity orthogonally to shock wave advance, and at a safe distance from explosion. This position allows to analyze shock front propagation and its reflection in wall face. At both test images were recorded in 8,000 frames per second with a fast cam SA3 Model 120 KC2 manufactured by Photon. Contour maps of damage having been replaced in external damage repairs appears to at sites like this, you can see. And his details of these rules results of external face of walls after both tests damage beds of points, and it is debris mass and mean damage obtained from debris hammer. For fragment analysis, a grid was drawn on floor inside and boxes as shown. As can be seen, debris mainly appear in tiling zone, referring to debris collected. In test M1 it was 63.4 kg inside room box and in 39.5. So here we can say, as can be seen, debris mainly appear in tiling zone, referring to debris collected in test M1. It was 63.4 kg inside box A and 39.5 inside box B. Test M2 to 48 kg of fragments were inside box A and 1.7 inside box B. Reminding let's see. Yes, yes. Fragment inside box is after rest, as you know. Blast effects on structural elements continues and says comparing results from box A and B. At M1 test, walls M1B with metal mass appears with a lower mean damage. Lower mean damage, and as logic dictates. Logic dictates because of external protection. Furthermore, there is an important reduction in spalling mass. Now comparing results from box A and box B, among test wall M1B, with metal mesh appears with lower mean damage. And so logic dictates because of external protection. Furthermore, there is an important reduction in spalling mass. Okay, let's first I will continue with this. Let me see. I must put on my shoes, and also cold. I'm feeling hot. This water will be in my lungs. So exercise. It's very cold. Again, very cold. Comparing results from. Let me see which log is this. Science Direct. Let me close it. Close it and fill it. Right, it's better, I close it so that unnecessary files are removed from here. Okay, this is already there. Let's leave it. So I close this one. Now let's see. So we say is comparing results from box A. Compare results from box A with box B with the metal mass appears with a lower produces a decrease on mean damage compared with M to B, and there is a strong reduction of debris due to inner basalt fiber film involved, and that is from 25 kg to 1.7 kg in M to B and 25 kg in M to A. So it is to 1.7 kg to B. Results from test 1 cannot be compared with those of second test. This is due to difference in lapse time between construction and test, which was higher for second. This alteration means that results cannot be extrapolated. Slabs and beams, considering structural elements, different beams and slabs were tested and analyzed. Test acronym is formed by a letter that refers to specimen to be tested as follows: S for slab and B for beams. S for slab and B for beams, followed by correlative number that reflects trial number. Different solutions were implemented and detailed in charge mass in terms of TNT equivalent, range from spherical shape to cubical shape, 2 to 15 kg. Detonator used to initiate explosive was located at center of charge. Scale down was from 0.2 up to 0.79 kg to power 103 for slabs and beam tests. For slabs, 9 specimens of 4.4 meter into 1.5 meter and thickness 0.15 meter were built using a reinforced concrete with nominal characteristic compressive strength of 25 MPa. Slabs were anchored at edges to concrete blocks. Slabs were anchored at edges to concrete blocks, pretending a rigid support. Shows this layout. Reinforced mesh was constructed with 12 mm die bars spaced 150 by 150 mm. In addition, some slabs had an extra reinforcement for protection purpose. In slabs S6 and S7, a steel sheet of 1.5 meter by 1.5 meter and a thickness of 10 mm were located on surface directly exposed to blast. Fiber reinforced concrete was used in slabs S8 and S9. For S8 steel fibers were used and polypropylene fiber for S9. The main characteristics of concrete, steel and fibers used are detailed in. Slab test setup 4 meters, can see planned by 2 meter. Here slab span is here 4 meter, and we can say this is thickness is 93 here and this is 15. Yeah, you can say it's in centimeters in fact, and here is, as you can see, this is the R1, here this slab, this support. If you plan of this is plan of this charge W, this is 2 supports here and this is slab here, this 15, and this is, you can see 93 is here, this is 93 right here is 93. So test specimen is here and this charge W says, and this is slab here, this is ground, this is ground. Explosive charge for standoff distance of 1 meter located hanging from rope, while for lower distances charge was placed on an expanded polystyrene cubic support. Note that expanded polystyrene cube used for test S9, S4. S4, S9 is just acting as a placeholder and possibility of a shock wave reflection on cube can be rejected. In case of beams, 5 reinforced concrete specimens were tested. Shows test setup and charge placement. Beams had section of 0.25 to 0.2 meter with span of 4 meters. Reinforcement consists of 4 holding bars of 12 mm in diameter, 60 mm diameter vertical stirrups, space 150 mm. Now, in case of beams, I have told already what we did. In case of beams, 5 reinforced concrete specimen were tested. Shows test setup and correct charge placement. Beams had a section of 0.25 to 0.2 meter with 4 meter span. Reinforced consists of 4 holding bars of 12 mm 6 mm diameter struts. Each beam was fixed at both ends with concrete blocks. For beams with 3 explosive was hung from a rope. However, for trial 4 explosive was situated on an expanded polystyrene cube support. So it is now R. Say, and you may say then. Beam test setup. Here is beam test setup. You can see this beam test setup here. Beam say this is, this is a beam here, and here is this your supports. Test the specimen beam. This height R. And this and just charge. Beam test setup. In order to assess in order to assure equipment integrity, measuring devices were only used. In order to, in order to assure equipment integrity, measuring devices were only used to test in tests with low explosive charges. S1, S3 and B1, B2 to calibrate and validate numerical models. These data are necessary. These accelerometers were used in each specimen, and two pressure transducers with ablative protection. In these tests, high-speed camera resulted as not very useful as fireball covered all screens. But information about blast phenomenon may be always extracted from videos. Results and discussion. Now, what are that? Let us see. Now, results and discussion. Now, this shows different parameters damage calculated. Rank is also included for assessment results based on author's experience and others. Considering D200, the parameters no damage, moderate or severe. While one of the parameters is below 0.05, damage is classified as no damage. No damage may denote appearance of little cracks, while concrete remains almost intact if one of parameters above 0.05 and below 0.15. Damage is considered as moderate, referring to specimen and important affected area, and moderate to have concrete spalling. Now, we can see these results here. We may see here, let's see test number here. S1, S2, S3, S4, S5, S6, 7, 8 and 9. B1, B2, B3, B4, B5 and let us say then slab beam, RC description, RC SSA, circle, whatever this means, and the meters, location of these. This is heights and kilogram, and this is M3 scale distance, and here is that. If I characters of these tests, let's say RC reinforced concrete, SSA steel sheet anchored on top, SSC steel sheet glued on top, SFRC steel fiber reinforced concrete, PPFRC polypropylene fiber reinforced concrete. And as was the columns is name, description or requires a density unit, or you can say concrete and steel bars, steel sheets, SFRC, PPRC, and this is density, and then compressive strength, and tensile strength, young modulus, yield strength, tangent modulus, fiber losses in concrete, length, diameter, specific volume. So density in concrete 300 taken, steel bar 7850, steel sheet 7850, and of course compressive strength 25 MPa, 44.16 and 43.33 in this case, and tensile strength is 3.7, 550, 8.12, 5.62. Then we take young modulus 273 to the power 2 MPa, then 200 into 10 to the power 3 steel bars, and 200 into 10 to the power 3 these were length as are given here. List of materials characteristics used in slab and beams. List of metal characteristics used in slabs and beams. Test number, again same list. Scale distance, assessment results, and points. Then damages, DNT 200, DA top, DA bottom, average area damage, D area, and this is and all this. We'll discuss this. And damage parameters for slab and beam tests. Results were asked for an essay test in comparison with damage maps being scale distance. Let me see the status of temperature moment is how much. That's also very important to know in this case. Is it's a factor. Let me see if we got something else here. No. Oh, well. Results for S4 and acid tests and comparison with damage maps being scale distance. So one, and we can see also if we have another file possibly, and that is 3D blocks protein structure, the protein structures critical homogeneous protein, peroxidase and plastic match. We have here I think designing structures, I believe last race is not unrealistic. Let us say this is yes, so we can save these two files as better if you save this file as well. File save as oh great, let me save this also. I forget the device. I can save otherwise also this one. I'll save this also. It's better if you save this also PDF. Yes, save as. So we go back to our old after taking this. Says results for S4 and SA tests and comparison with damage maps as being scale distance. Take this otherwise. No. Results for S4 acid test is as this methodology reflects when reducing scale distance damage increases for slab sessions. They reflects when reducing scale distance damage increases for slab. These are slabs without additional reinforcement. For slabs with steel sheet, this will increase in the area damage about 15 to 4% respectively when compared with same configuration without steel sheet. Nevertheless, bottom part results differ by 5%. The same scale distance steel and polypropylene fiber slabs. Relative damage the one is almost same compared with slab S5. Furthermore, when considering area of damage on top surface, values are also very similar. However, at bottom parts, differences are noticeable. So what we say, as we said already, also shows data obtained after blast events or 5 beams tested. In this case, additional reinforcement material was implemented in beams. So studies only based on reinforced concrete beams damaged has been evaluated at 9 points on top surface of beam, which was only exposed to explosion as slab test results. Even scaled All right, we go further here. Now you can say we have to interpret later on also. As figure 9 results of before B5 test in comparison with damage maps is being scaled down. In numerical simulation, reinforced concrete slabs and beams were reproduced using 3D solid Lagrangian elements, while explosive event is implemented with conveyor. Steel rebars was incorporated into concrete mesh using LS Dyna command. a constrained language in solid. Using this feature, we assume a perfect bond. There's no sliding due to short ever time when time and high blast pressure. Save save computational time and taking advantage of symmetric conditions. Only one half along the x-axis of each slab is considered. More details about model can be found. Explosive charge has been introduced into model by load blast enhanced function. This function is based on Kingery-Bulmash empirical blast data. Plasticity based material default based material model CSCM was used to simulate concrete material in slabs. CSCM model has option of inputting your own material properties or request. Okay, now results of numerical modeling can be used you can say where was a plasticity based material. I was missed somewhere. So let me see again here. Plasticity based model CSCM was used to simulate correct concrete material in slabs. CSCM model has the option of inputting your own material properties or requesting default material properties for normal strength concrete. Can say concrete material in slabs. So system model has an option of putting your material properties or requesting default material properties for normal strength concrete, introducing only compressive strength. In this case, second option was used in this material type concrete. Okay, now results of numerical modeling can be used to compare results of field tests, and if good regiment repairs, results can be extrapolated to other cases without need verifying by numerical modeling of S8 showing plastic strain and comparison with photographs of tests. You can slap on. Explosive charge has been introduced into model in same way for slab. Same material modeling have been used for concrete and steel. Shows plastic strain processed by numerical modeling for B4 and B5. And comparison. Alright, then we go further here on this. We have seen this here that explosive charge when induced in model in the same way as for slabs. So same material models have been used for concrete and steel. Shows plastic strain produced by numerical modeling for beams before and 5 in comparison with photographs after test. We can see comparison of numerical models for test before 5 and structural integrity. That is, what is that? One different structural elements and weak elements of a building have been tested. Once different structural elements and weak elements of a building have been tested, it would be desirable to know behavior of complete structures subject to blast load. This kind of test is really difficult to implement due to element dimensions, but mostly because of high cost. Once different structural elements and weak elements of a building have been tested, it would be desirable to know behavior of complete structures subject to blast load. Kind of test is really difficult to implement due to element dimensions, but mostly because of high cost in test shown here. Behavior of frame present. Now we say this kind of test is really difficult to implement due to element dimension, but mostly because of high cost, and that's shown here. The behavior of film structure after removal of blasting of its columns analyzed experimentally, and correspondence of this scenario with thermal calculations. This is checked. Structure analysis was two-story reinforced concrete structure. Slab have dimensions of 40.35 into 11 meter wide, including these measures 2 meters. Anti-national column removed. Here is in this building foundation slab. Here is first floor and this is second floor. What to do? Figure 12. A geometrical detail of structure laser profile used to measure permanent strains. High-speed camera detail of PM to be removed. Removed. C. Laser profile. Now, column to be instantly removed with explosive. Explosive was one of central column of main floor for demolition of columns for PG2 cylindrical loads 200 gram each were used. In sensitive instantaneous electric detonators were used and connected in series. Text was monitored following equipment. Laser profile, robotic total solution that allowed to scan structure and to evaluate permanent strains. Accelerometers, 4 accelerometers connected to fast acquisition system. Seismographs, you can say. And seismo, what's that? Sorry, I missed that line. Yeah, seismograph recording of particle velocity and airwave pressure microphone. 3 axial and 1 uniaxial geophones. High-speed camera analysis of different phases in moment and evaluation of displacement and velocity. And 2 high-speed cameras were used. Results and discussion. After column was removed, the structure collapsed. Accelerometers and seismographs were trapped in debris and could not record anything. No measure was possible with laser profile either, as there was no permanent strain after collapse to be measured. High-speed camera video made possible to evaluate falling speed of slab placed on column removed. Measurement contributed to calibration of corresponding simulation. You can see 0.4 seconds, 0.7 seconds, 0.27 seconds, it is 0.6 seconds, 0.1 seconds, 0.6 seconds, and 2.1 second, 2.6 second, 2.6 seconds. I think I'd go for 5 minutes for that, right? So 5 minutes, come back, alright? Just a minute, go 5 minutes, come back, right? Okay, let me take my, yeah. So, just few minutes more we discuss and go. Sequence of tests recorded with conventional camera. This is here conventional camera. As a result of test was total collapse of structure. No more information could be extracted apart from visual data. Videos recorded, hence importance of achieving intermediate levels of damage in trials to produce, and analyze behavior of structure. Numerical modeling was used. As in previous cases of this work, 3D model with Lagrangian mesh and convex blast load description is developed. Also, same material models CSCM for concrete and piecewise linear plasticity materials model for rebar have been used. More details about model are included in Bermejo. Models used for reinforced concrete structures have proven their capacity to reproduce complete process of progressive collapse. It shows from video recorded 1.1 second and comparison with numerical models of already. It's time. Now we had another file here. This is, I think it was somewhere else. It's right. I know there's something that no, it's not. This is, well, I think I lost that one. This is quality PDF. Is that file? Let me see what's that file. Is this one? This is. I think I lost that. Concrete blast effects on this. Then regards concrete blast walls. And this name both concrete quality. I think that's what comes on somewhere else. See, but not that. So it's that one. I start. I think. This is the article here. I've taken this already. This is IIT-C. I think I did this right, is it? Let me check it if I've taken or not. So I see as let me see. It's concrete. I think I've taken this. Concrete. I've taken this. This concrete. Let me check in concrete. I've taken this concrete. This must be. I've taken this. I've taken this. Last practice cold weather concreting. No, this is not that. Concrete. The cold weather concrete. And that's also. I lost that ISO, I think. ISO I lost, no problem. We'll check that one some other time, no problem. Let it go. Let it go now. Okay, no problem. I lost that file somewhere. That is sometimes not there. And let me send you pages more. Yeah. It's not that. It's something else. Why is this? I think there's something advertisement in this. Solid advertisement. There's nothing much left in this. So major portion we have covered, and we will take it later on. We'll take it later on. Now we have covered many pages, and we'll see how it works. Let me see if I can do something here. In this case, let me go back this and let me see how this. Yeah, this is recognized as buildings, IIT, and this blast building structures associated, and this is protein. Other structures with various blast loadings, and then we have blast in the structures, blast protein buildings, blast analysis sciences. Course, and it is where's that? I use some PDF researchgate. Not this one. Springers.com. Something is missing somewhere, I am sure. Plus RCC. It's gone. Design still structures. Let me. Maybe I missed something great here. I think I missed something. Yeah, it's here. I got it now. Criteria plus for is here. Let me see if we can do it or not. It's I see. Of course, it is Bharat one. So we'll take up this issue also. It's not moving exactly. So this is ours. We'll take up this just to know what is there. In fact, just to know how does it work and how does it work. Let us see. It's of course old one, but let us see what contains. Will something good or not in this. Maybe it's not very descriptive, but informative only, I think. We'll see it later on about one structures. What it says, it is copied from somewhere, or this just original one. You will see this also, and okay, we'll see. There's no time now to see in this. This is PDF files, so we can start. We can continue to save it. Can it? I don't know whether can I save it or not. It is now saving. It's download. I think it's download. So we have to download and save it. That's the only way. So let's download this. Here is concrete blast. I think this is that one, right? No, it's not that one. It's not that one. Okay, it's this one. So let's download it and save it. Only way is this. And this is iso concrete, so I can say concrete. Blast. Let's see blast. Okay, save it and finish. It's okay. What to do? Alright, so I'll close it now. It's over. It's over. And we go back to our file, and we'll conclude this now later. So we have taken information about blast and about quality, which is very important one. Get up quality, and you have to be very serious about that. Get up quality. We'll continue our get up status, get up quality, and we have to get up ourselves, we have to challenge ourselves, we have to ask ourselves, we have to get ourselves. That's important here. And engineers have to handle all this, and we can handle all this when you know everything about this in the design and about execution. I'm not design expert, but theory everybody knows, and if you read book, you know what you learn. Of course, I'm not experienced very well in designs, but no problem. It is only awareness. I'm not here to design something. If I have to design, no problem, I can design that, but I'm not interested in that currently. So we can say let's get up quickly soon and understand what to do. So my address is to quality, that get up quality, come to us, we discuss together. We discuss together and in third round, our view, our way, what is way, what's not way. That is also very with this. I'll take your leave. This. Thank you very much.